Hi, welcome to this Open Security Summit session in December 2024. And I want to cover a lot of some of the workflows that I've been using recently, especially since I do a lot of development these days, that in a way fall into the DevOps. And I feel it's an area that it's still, not as mature as it should be, because I actually spend a lot of time to get this workflow done. And it's one of those areas that I feel that we really need to define better what is the minimum, also what is an MVP, minimum viable prototype for any application. Because I think there's sometimes this idea that you start developing, you do stuff and you add the DevOps and the automation later on. The problem is that very quickly it becomes a mess. Very quickly you start to have technical debt to the point of view, or you slow down, and very quickly you don't almost have time, because then the whole thing of product development and pressures, etc. And I actually think that it's critical that you set the foundation where you're releasing all the time. So it's almost like you need to get to the point where you're releasing to a kind of production state all the time. And I'll just walk you through it, how I'm doing it right now, because I think that makes a massive difference. And GenAI is literally the killer on this, right? The GenAI is the one that really allows me to do this. And I want to give you some examples on how to do it. And I actually don't have a lot of Terraform at the moment, but it's a good example. So I was kind of going, all right, let me show you a good example of what I mean by the power of GenAI to understand this. And I really feel that the real situation with the GenAI technology, and I have other sessions that talk about it, is not about having custom models, it's not about having more black box, which I think is always dangerous, right? Because you need to be able to debug everything you do, is actually to allow you to understand better what you do. So a good example is we have a lot of people that have Terraform, right? And Terraform has this thing that says, yes, it's descriptive. It does what it says to do. The problem is, I think it's just about everybody who has Terraform stuff, right, and CloudFormation, etc. You don't really know how the hell the whole thing works, right? It's there, but you really need to be able to visualize. You need to be able to map it. More importantly, you need to be able to start to diff it. And that's one of the things that the LLMs are really good at, right? So, for example, you can literally take that text and you can say this. Can you create a number of diagrams, right, from these scripts, right? And you can also say then put them in separate files so that so these I'm using Claude 3.5, which does this workflow quite nice. Visual, right? So sorry. So basically you could see here that all I'm doing is literally copy and pasting the stuff from there. I submit this. And what's really cool about it is this kind of stuff, the LLMs are really good at, because actually the best explanation that I've heard and I figure out that the LLMs work, it's not a text predictor. I think that's really, it's like underselling what it does. Yes, there's a point where it's predicting the next word, etc. But before it does that, it creates an object model of what's happening, right? And that's the key part. The key part is the LLMs are able to go from here to an internal representation of what that means. And they're very good at doing this when they parse the information in the way they parse the prompt before they start connecting the output. And it's that model that we are accessing. So in a weird way, we want to find ways to enrich the model that the LLMs can create, because the better that model is, the easier they can do, right, their answers. So if you look at this, right, just by feeding that, and that's really like not well parsed, it's just a dump of JSON in this case, you can see that we already have some really nice diagrams, right? Terraform configuration, the provider, the security groups, the instance that is there, right? Then in this case, you have a mapping of the security rules that actually went into it, right? Now, what you want to see, and this is where security actually has a big part to play on, there's a lot of things here that are really important in security. And one of the things that I always want to be able to ask, for example, on deployment, and when people are shipping code or doing, fast deployments or have all these scripts, is what has changed from a security point of view. So you could see that, for example, right, there's a lot of actually security, in a way, some concerns about this, right? Because it looks like from here, you can have SSH from the outside world, you can actually access 80 and 443. So we can now say, oh, hold on, I want to know about this. but we can now then do further analysis on top of this. And this is the kind of stuff that I think people should be using a lot of GenAI, which is to use it to understand and to make changes and to basically speed up the development of a lot of this sort of infrastructure and plumbing and almost like this sort of scaffolding that we put around software development that actually makes you code faster. So I have this practice now where the more code I add to my app that I'm developing, right, the faster I go. And that's a really cool thing to have because I spend a lot of time on the pipelines, which I'll walk you through it. So this is quite interesting because you can see there's already some security concerns in here, right? So, and then you got the security groups and then you got the dependencies, right? So I can actually go and says, okay, can you do a security review on this deployment, right? So this is actually really cool because now you can start to say, what areas of recommendations you can have, right? So what areas of that we can do, and then in this case you go, okay, so you can actually see, right? It actually very correctly picked up the fact that we have inbound HTTP, we have over permissive rules, there's tagging missing, there's VPC configurations, and then missing encryption, which is an interesting one that could be higher, and etc. Right? And actually, I could even expand on this and say, okay, what about? And this is where the whole point of this is not to have the final answer. The point of this is to be able to have a dialogue. The point of this is to be able to interact with the information, because ultimately, let's say if I was doing a security analysis on this, I still own the final result. I still need to verify, and more importantly, there's going to be enough humans and enough reality in the loop that any mistakes will get picked up. But the fact that you can now edit things like this, the fact that you can manipulate things like this is absolutely super critical, right? So I could say, what about port 80 and SSH, right? And you can see how cool it is, right? Like, I can now, do a conversation about it, right? And I can basically say, okay, port 80 SSH, I didn't actually have to talk about the fact that port 80 is actually, SSH is 22, so he understands that, right? And port 80 is HTTP, right? So it's really cool, right? So again, unencrypted allowed, and then, it has actually, look, outbound SSH unnecessary, so actually replace SSH, oh, that's not a bad subscription, input batch, etc., right? So in fact, before we do that, I would like to say, yes, can you create a new Terraform script with your recommendations, right? Which I think actually might already created. Yeah, so you got that there, right? So now you got a more secure version of AWS, so the Terraform script, so you could see, actually, this is actually now using HashiCorp for some of the stuff, right? Is now you're going to have a Bastion server. But again, you look at this and going, okay, what's actually going on here? In fact, you can actually see this more complex, which sometimes is the reality. Sometimes, security does introduce more complexity, right? And then, but it's even cool because actually it has a Terraform file, it's actually really nice. So you can actually start to see that you start to segment the stuff, etc. So I can go, can you visualize this new script? I can go, yeah, script. So now I'm going to get a visualization, right, of that, the new architecture that we just created. And this is the kind of workflow that I say that people need to start having, right? And you can see how productive I am. I'm very productive because, look, we went from the other design who had a whole bunch of stuff, where now you start to see, look, in this case, right, you got, let's take a look at it, security group, the network architecture, the private subnet, right? And this is where you then start to adjust, right? You start to figure out, do I need this? I don't need that. What do I want to have, etc., right? And it's actually quite cool, right? You can see the dependencies, how it works, and you can see, okay, so and then you can go, okay, so on the new architecture, new design, which ports are exposed, and of course that if you then have standards, you can then map the standards to this. You can then say, we use this, we use KMS for this, we use HashiCorp for that. This is how we do things. We use Bash and host, etc. So it's a really cool thing to be able to say that. So if you look at this, now you have in fact, what's very interesting about this, if you look at even this diagram here, this already looks like a threat model, which is exactly where I was going to. You can see we went from the original design. So if you look at, remember, the original design that we actually had, which was basically this. You had 4 ports exposed to the internet, highly permissive things. It literally was, fundamentally just this, right? A bunch of stuff that came from here to actually a really cool architecture where you now have one internet zone with 443. You got a Bastion host to connect to this. It goes to SSM servers, connects to the EC2 instance, security groups, package it up, ingress rules, all ports blocked. Now we're talking, right? That's really cool. So now we can even take next level and say, okay, can you do a threat, right? A threat model on both versions, right? So and this is right. This is the kind of stuff that we used to do more manually, right? But I hope you start to see the power, right, of this kind of development, because now we can create all this stuff and then share this information, right, with the teams, and then even more interesting, you can operate on top of this. You can start to make changes on top of this, right, which is a really cool thing. In fact, look at this view, right? You got threat modeling. There's the previous ones. Can I zoom in on this? Let's see. Yeah. So now you can see here we got spoofing, tampering in the secure version, denial of service and medium, where the other one you had quite a lot, including, because of course you had HTTP, etc. So look at the differences between the two designs, right? From there to there, right? And this is actually quite cool. Look at that. You got an attack tree comparison. It'd be cool to map this to Mitra, right? So you now have, limited attack surface, HTTP only, etc. Where here you got a whole bunch of attacks already mapped in there, right? So, and we can continue, right? So you can say, okay, can you put this side by side on a table, right? And remember that this is DevOps, right? Like in a way, this is the kind of work that you want to be doing on DevOps, because you want to be coding and automating and visualizing, understanding what is on your pipeline. Because the more you do this, the more you can actually understand, and the more you automate, and the more you, in a way, you make your system more effective, right? So, all right, cool. So there you go. There's a nice table. I'm probably going to ask, right, to actually put it on text. Okay, so this is quite cool, right? And then there's the exposure levels. Okay, so then you can say, all right, okay, can you create a document with this information, right? Information, including the tables, right? So now we can have a document that we can then share. We can create pips. You can, well, I call it like the sort of enhancement proposals, or like a whole Amazon walking backwards. So it's really cool, right? So you could start to then do this. And one of the things I also do is you can also start to edit this. So you can kind of, let's say I have this document here, right? And you could see, put a table there. So one of the nicest things of this mode here is you can turn around and say, okay, cool, can you put this, let's say, okay, maybe the first one, can you put this on a table? So you can go, can you make a table with this, right? And you can, again, comment here or comment there. So you start to see the workflow, and then Claude is going to replace it. There you go, right? So, it's not a bad thing, right? Like, if you look at it, even very quickly, we went from one to the other. And what I like about all this stuff is that I feel like if I'm now communicating, that's from a security point of view, with a DevOps engineer, or a DevOps engineer was communicating with a security professional, this is how we should be talking to each other, right? We should be presenting the data, mapping all there, and then taking from there, right? So there you go, right? That's a pretty cool, quick document. You can see I created this in like 10 minutes, right? You can see how, look at that, right? Nice money shot, right? So there you go. Really, really cool workflow that I just wanted to show you, because, this is the kind of stuff how I operate now, and I'm super efficient, right? Okay, so now I want to go into another section of what I want to talk about, which is the pipeline of deployment, right? So one of the things that I want to cover is this API that I'm working on for being able to provide news feeds, and in fact, be able to provide the Open Security Summit, which I already got here, right? So in fact, you can already see this in action here. If you go static dot index dot HTML, you can see that I already got two APIs, one for news, one for the Open Security Summit. If you go in here, you can see I can now get, for example, the feed data from, this is actually from Hacker News. Actually, so this is, yeah, this is from Hacker News. I'm going to add a bunch of others. So this is basically transforming. In fact, you can see the sort of the RSS XML soup that you get, which is kind of that stuff there, into a nice, formatted. You can see here a JSON file. But more interesting about this is you can then take this and actually you cannot get it from here. You have to get it from the other one, but you can get a prompt, data into this. What's powerful about what I just showed you and this example here with the Open Security Summit is that these files, let's say the file of the current event, the one that's happening now, which is, look, you can see here, there's all the information about the current event, the sessions, the people who are doing, etc. All of this is actually pure S3 files. So it's a very cool design because there's no server, right? I actually have the equivalent server behind, which is actually here. So you can see this actually has a couple more features, a couple more stuff, and you can actually see the structure. You can see the files on the back end. You can easily see the prompts. So for example, here's a prompt for this, the current summit. So you can see here, we basically say, hey, here are the sessions, and then here are the detail about the different sessions. And then, at the end, you got information about the presenters, right? So, it's really cool because, this is a good example of an API that's been developed and being published automatically. What I want to show you now is the DevOps pipeline, and I use, again, a lot of GenAI to help me create that pipeline that goes into place. And the pipeline actually looks like this, right? So you got actually two, in fact, my pipeline here usually has two elements. You have a dev and you have a main, right? So usually the dev does this, right? It goes run test, increments, tag, and I'll cover that in a second because that's super critical, and publish to PyPy, which in this case, I don't actually need it, so I kind of disable it. And then when you look at the main one, this is where it gets really interesting, right? What actually doing with, anyway, with every release to main is you basically run the tests, increment the tag, publish to PyPy, publish to AWS ECR, and some other projects that publish to Docker Hub too, deploy the Lambda function, and then run QA tests. The thing, and in fact, if you look at the custom data feeds, the one I was just showing you there, basically this project, it has the same pipeline, right? You can see the pipeline is exactly the same, right? You do the same thing, run the tests, increment tags, publish, etc., etc. The thing that I really want to stress here is that in this particular example, which is this one here, the OpenSec Summit, actually, I haven't actually added more functionality. So, but what I've done was I've implemented everything that I would say is the minimum requirement before any project, before you add any functionality. And what I mean is, that I make a code change here. In fact, I haven't refreshed it, you'll see. I just made a code change to this repo, right? And I'll show you. So I just basically, I made a change where I basically added a new ping method, right? So I came in here and I added a ping method to this. You could see this is just the way I tend to try to simplify fast API, which basically it's, how can I just feed the file? Where I basically, where's the option to just see the file? Oh, browse files, here you go, right? So basically what you have here is you got a fast API, you got a route. So it's actually really cool, really simple, right? Fast API, this is all open source. This is the open OWASP Open Security bot, right? You got there, and all you have to do in order to create a fast API, actually for reference, is you have a base file that looks like this. This is almost like the MVP, right, of MVPs or Fast API, right? You just override that. So that's my version of Fast API, right? You just set the base path, you want cores or not, right? And then you add these routes info, right? So basically you say load all the routes from here. This basically implements the routes Fast API. Again, I wrapped up all the complexity so that all you have to do is have this method, which gets overwritten here, and then you just put the methods that you want to put in, and automatically this will make them all into the Fast API setup. So, but what it means you can see I add this new method called ping here, right? So this method now doesn't exist here. If I refresh it, it should be there. There it is, right? So that was the method that I just added. So you can see that I went from, in fact, this is technically production, right? So, well, theoretically, this will be QA then or staging, because usually I'll have this, and then if this is good, I then have a manual final change, right, for my, I guess, production, right? So what you have here is this basically method, which I just added. You could see ping pong, right? Is basically was all mapped out, right, in the sort of in that workflow automatically. So what this means, it means that before I added any business functionality, in a way, before I go from here into here, right, I basically have a workflow where I can make a code change into this API, who then runs the unit tests, and that's a very important set of tests, which I'm going to show in a second, right? So the first thing I do is I run my tests, I increment the tag, and then once that, the reason incrementing the tag is so powerful is because it tells me straight away that the tests are all passing, right? And I know that once my tests are passing on my dev, and sometimes I have a more, I say, bigger deployment in my dev, I'm comfortable that I can merge into main. And this is one of the key concepts here. Your main branch should always be in a state that is publishable. In fact, you want to publish to main as fast and quick as you can, as long as there's no side effects. And that's why you have your tests, to give you coverage on that. So the more tests you have, the more confidence you have. And also you have to spend a lot of time making sure that your tests are well maintained. I actually would argue that your test code and test infrastructure is more important than your main code, because it has more yield. What I mean by that is, I mean, the better your test infrastructure code is, the better you, and the easier it is for you to test, the more effective your main code will be. So yeah, i.e., yes, your main code is what the user's experience is, what ultimately, you know, adds value. But if you don't have a good test infrastructure, you won't have good code. It's literally, it's that simple, right? So what's super powerful here is you could see I made a change, I increment the tag, and then I was happy with that. So then I basically published my main, which then, just to reiterate, without having any business functionality, I go from, I increment my main tag, I publish to PyPy, I publish to the AWS ECR, a container, so I create a container, immediately I have a container with this, and I deploy the Lambda function. And the Lambda function is here, and in fact, I configured the Lambda function already with the function URL, what you see there. So this is literally the Lambda function that I just deployed with this version, right? So let's see all this action, and I'll explain you some of the steps along the way. So if I can actually even do this online, right? So why don't we do this online? Which is cool, right? So if I come in here, and I'm going to go into my code, right? And I'm going to go into that version. And actually, before I do that, I want to show you one little thing here, which is that version on here. And it's kind of probably a better visualization to show you, right? So what you have here is what I mean by versioning, right? So this is a simpler version, right? You know, this is a bit more let's say my data feeds, it's a bit more complex. You could see, you know, you could see the constant push and pull. And then, you know, if you look at, you know, some of the cybersecurity sort of boardroom that I'm doing, you know, it has a bunch of stuff that is going like that. You can see a lot of these are internal releases, right? So you can look at this. I'm releasing all the time here, right? And in fact, in the cyber boardroom, I then have this main one, which I use, again, poetry.lock, to bring the versions in, right? So you can see here, I bring the versions in. So this is kind of like my main sort of project, where all these other dependencies can then come together, and then I release them. And I know that if everything passes here, I'm good, right? So I don't have to worry about it. So just to reiterate, like the way you read this part here is that was my first release. That was my first release to dev. So every release to dev increments the small number. When I push into the main, which in this case is in blue, you can see that I get a version increase there. And then I push to dev here, and I push there, and I push here. In fact, what I've done for the data feeds, which was actually quite cool, is I actually called my version 1.0 that version that only had what I would call the MVP of this project, i.e. everything to the Lambda function without any business functionality, and then I added my code. So you can see here, you can see my publish to dev, merge to main, 1.4, then I got dev, and then etc. And sometimes it doesn't work, sometimes it fails, sometimes you do development locally, sometimes you go a bit like this. You can see I went all the way to version, in fact, I'm all the way to version 1.17, right? One here, right? So you can see that it keeps increasing, right? So it's pretty cool. Right, so let's make our code change so we can then see it in action, and I'm gonna leave that here, right? So I'm gonna come in here and I'm gonna change, let's say, my routes, and I'm just gonna change the value that it returns, right? So I'm gonna come in here, I'm gonna edit this file, I'm gonna say Pong edited, edited on live OSS session, right? So I'm gonna have here, right? I'm gonna commit my changes. So this is where I could do a branch, I could do a branch, then I can do a merge into dev. So it depends on your workflows. In this case, I'm going to push directly to the dev branch, but this is again how your workflows. Just remember that as soon as it hits the dev, it should be ready. In a way, the concept is anything on dev that passes everything should actually be able to be sent to main. Everything on main that passes everything technically can go into prod, right? And then your prod sort of decision is more of a business decision, when you want to introduce new versions, when you want to share this with users, or all that jazz, right? So, okay, so we've done our change. We should now have a new test. You can see here, update routes. My tests are now running. So you can see that I got my tests, I got my repository. He installs everything, and then he runs my tests. Now, the thing about this is that actually, in my other projects, I actually would not be happy that this passed. And the reason why is I just changed the functionality on the application. So I really should have a test that verify this, right? On this. And basically, which I don't, which is actually a problem, right? So in a way, we actually, this, again, test coverage is about giving you confidence to change, right? So if you make a change that doesn't break a test, and a lot of times you probably make a random change, unless it's refactoring. If you're refactoring, it's the other way around. Refactoring, you want to make lots of changes without changing the code or without changing the tests, right? Because the tests confirm the functionality that is already happening, right? So you can see, so basically now we got my test, I got my tag, right? Published, which is really cool. And what this means, and this is actually something that is hard to explain, but it works really well in practice, is I can do pushes sometimes, and I don't even need to go to GitHub, right? To know that my test passed, right? I could see straight away from here that my test actually passing. Now, one little mistake I've done is I should actually have bring main into the play, which I didn't. So I'm just going to fix this. I'm going to merge this, and I'm going to fix. Sorry, I'm going to check out that. Check out main, and I'm going to merge with this guy. Yeah. Okay. Cool. So now, so what we now see here, and actually this is, again, there's going to be a little conflict here, right, which you can solve. Again, you can easily solve this in, actually, let me just see if you can see you can see the right click. So it's actually, you can see that my version, in this case, is correct, not the other one. So there's actually a cool option here. Let me see if I can show you. Yeah. So you can just go resolve conflicts using my version. You can see there is my version because mine is 2.1, the other is 2, right? So I just do that, and then I commit on this. Let's just not do that just yet. And okay, so now you can see that what I've done here is I fixed the little conflict that existed. I now have a local main branch that has the changes that were done in that, right? You can see here, there's my route changes that I've done, and now came into that guy, was put into that one, and now put into this one. Now, when I push this into the main, what will happen is you're going to see now that whole workflow kicking in. And again, what's powerful about this is after a while, it starts to be second nature. So I kind of know that this is going to go all the way to production, right? And that's super critical. because in a way, what this allows me is to have confidence in my pipeline. I know that I get a Lambda function on the other end, so you start to treat things like this. Now, you could also make things to make your development more workflow. It's also, for me, what is critical about the DevOps workflow is that a lot of it is about making the devs and the DevOps, of course, too, more productive. So lots of anything in my book that makes somebody more productive is worth spending the time to do. So what you'll see here is on the dev of Cyberboardroom main, there's a couple little things where actually when I increment a tag, I push to PyPy. I had to put this because PyPy is non-deterministic for some weird freaking reason, right? You publish, you confirm, you come back 2 seconds later, it says it's not there. So I really had to do that. And so in this case, I actually deploy two Lambda functions. I deploy a Lambda function that literally has just the code. So I do a trick to replace the code. And then I deploy another Lambda function that actually uses PyPy code on it, which is basically one of the key tests that I have. So I actually have, immediately, this will give me 2 websites. In fact, that trigger deploy is actually another GitHub workflow, right? That deploys the community site. And then when it's to main, the main here is a little bit more complex because it does a couple more things. In fact, it's actually simpler because I had more pipelines, but it does the thing increments, publish to PyPy, waits for it to publish, put on Docker Hub, push to ECR, deploys the Lambda. I actually had AWS EC task. I actually had GitHub here. So I had Google Cloud too, and AMI, EC2, just that, because I'm not fully using them in some of these workflows. That's for another places, so I kind of took them out. But here was really cool. I got a point where I was literally deploying to Google Cloud, AWS, Lambda, EC2, ECS, right? So I can deploy this anywhere, right? Which again, super powerful. And you can see here I'm deploying to dev, the community dev, and the QA dev. And the QA dev runs exactly like my prod, and then I can then merge in my community side from QA to dev, or in my main side from QA to prod, sorry. And then that actually pushes to my main prod thing, right? So let's see where we are. Okay, so we got the PyPy publish, we got the ECR. So while that does, there's a couple more things I want to show you, which is these tests. So the powerful of these tests is that there's a lot of already advanced techniques in the tests that you see here. So you can see there's a bunch of tests here. There's setup routes, version, base path, etc. right? On this test, and actually that's my unit test, and then I got my integration test, right? The thing that I really want to stress here is that, and there's literally very important code that goes into this, right? Which again is open source, you guys can use it, which is if you look at the tests, I have 3 sets of tests already. And remember that this is all done without adding one line of business functionality, right? So I have 3 types of tests. I have my unit tests, which by definition should have 0 dependencies. It literally runs off there's nothing live. So you can see I check my route, I check my versions. So that's just simple tests on this. And I also have a fast API. So this is again is a test that literally runs fast API locally. It doesn't start any server, doesn't do anything. So you could see I check the base path, remember that high enable cores is true. And I also check the paths. Now, this part here is super critical because it's almost like my security canaries, right? I make sure that every time I change the attack surface, I leave a very strong sort of trail behind. So for example, I actually force every time I make a code change in a route, I need to add this information on what routes actually got added. So I know straight away the entire attack surface of this application. Very useful when you're doing threat models, for example, right? But also it allows, the way I think about this, imagine the biggest system, you can easily monitor when the attack surface has changed, right? And that's, again, the great question to ask an LLM on this, right? Now, the other thing that's super critical, that's the unit. The integration tests, there's some really powerful techniques I use here, so I want to go through, right? So the first one is I create these shared objects. So especially for more complex applications, this is very important. So I don't recreate everything all the time. So this gives me, for my tests, my fully configured fast API object, set up already. So sometimes you have databases to run. In fact, I'm using a lot of times local stack, so that sets it up. You get the fast API and you get a nice client. The good news is when you have multiple tests, they can all share this, right? And they should be able to share because there should not be a lot of state around it, right? So the first thing I want to show you is in this part, you could see here, and I kind of use this convention. I kind of arrived there, because Python doesn't like when the tests have the same name, but also I quite like because now it gives a very visual clue of the type of test you have. So you have integration tests, you have HTTP tests, and you have client tests. So integration is, I need a server kind of configured and sort of in a way that I can invoke it, and probably going to invoke dependencies. So that's kind of more an integration test. The client actually simulates an HTTP call using the fast API, and the HTTP actually makes an HTTP call. So you look at this, right? From here, I'm actually able to create these three-dimensional tests into my fast API. And I'll show you. So the integration tests, what it does is imports directly the routes info object. So let me just show you here. Is basically this guy here. So this is my routes API. So I'm going to invoke these methods directly here, right? And basically these methods, I'm having no state, I have no server running, I'm literally invoking just the routes. And this is super powerful when you're doing development. So I do lots of development where I just work at this level, and then eventually I start to wire up everything sort of above. And my point with the DevOps thing is that this is all what the DevOps pipeline needs to do, right? This is not just development. The DevOps pipeline needs to care about all this, because this is literally the fundamental development operations. This is making the developer more productive, because if you don't have stuff like this, you can't test properly, and the whole thing becomes a lot more, brittle, right? And not very solid. So you can see here, I'm literally just invoking that. That gives me the routes. I get a nice method. I can check the version in there. And in this case, I just confirm that my version, which you can see here, returns this value. I confirm that it does work, right? So you can see here, I'm actually invoking the Python object directly, right? That's why I call it integration, because usually it's going to make some calls to outside. Technically, you can make this a unit, but this feels already more like an integration because you already have something alive there, right? So the client one is interesting. Now you can see the client one already, for example, confirms to me that fast API is working. So you can see that the client one is, I'm not invoking the test directly, the code directly, I'm invoking via fast API, which is why I need to use this. So yeah, I'm actually put a route there, which is the fast API route. So when I'm developing here, see, I don't need to go to the live server. So for example, here, I wouldn't need to go in here, right, and refresh this to confirm that the server, the new route is working. And because every time you do that, you lose context, you slow down development. Like this is the thing, right? Development and DevOps, etc. You're always testing. The question is, if you need to click on anything to do a test, it's a non-deterministic test. And you don't repeat it, right? So you don't get this flow. Where, in my case here, I know that if this test passes, I know that my route is up and running. I know that it's working. And you can even take it to the next level, which sometimes is needed. You could also have an HTTP. And this is one of those things where, the first time I hit this, what I tend to do is I go on a tangent. So the first time I had this problem was like, how do I start a fast API server? So then I go on a tangent and I build support for that. So then when I come back, I'm, again, hyper productive. So in this case, you can see there's this fast API server, which again is part of the open source fast API utils. And what this does is this will literally start a fast API server in a random port locally, right? So and you can see like the setup class starts the server, checks that the port is open. Then when I tear down, stops it and checks that it's closed, right? And then now here I can actually, and I have this little helper just because it already puts in the URL, but you can actually see what it does here. So again, it's not very complicated. All it's doing here is just adding up. There you go. It just grabs the Lambda function, right? Actually, this depends where you are, right? Actually, this is quite cool. This is actually a QA one. Oh, it jumped to the QA one. Interesting. That's a little bug on what's it called? Because that's not the QA one. This should be, HI should be giving me a different one, right? So, which is the one that has a local host, right? So basically you got there, and that actually is going to make an HTTP request locally, right? So again, look at these three things. In one go, I basically have a direct to the class test. I have a fast API test, still not live. So sometimes there's bugs, there's problems that only occur when you actually make a network request. And that's what I do here. So this last one is a network request. Again, remember that all of this is done without one piece of functionality being added, right? So now you can see I got my 3 tests, which already covers this quite well. And then the fast one, which is what you can see here at the end with this part here, with my QA tests, right, is my QA tests actually run on the Lambda function. So that test, and you can actually see here, the deployment should have worked, right? There you go, right? See, there's our deployment. See, it's really cool. Like, I know this thing already works because I've seen this happening so many times. So I know that if my test passed, in fact, the only thing that annoying me here is that I should actually have a test that confirms this, right? Before I even arrive at that point, I should already know that that text I have maybe is on a constant is actually the one I get on the other side, right? But then the final test is an interesting test. So the final test I got here, which is the test that you could see here on this kind of final step, which is the QA tests. That's a test that is designed to run on the Lambda function, right? So it's designed to run on the actual QA server. So for example, there's a test here, which I got here, which cannot be run locally. In fact, I even have a check here to say, don't run this check locally, right? Unless you are in a GitHub action, right? Because that gets invoked. So I cannot run this test locally because this test is actually checking for the version, right? And the problem is that the version has been updated, right, with the release. So you, in a way, it means that if I run this test locally, it's always going to fail because unless I've updated my version, right? Because in principle, the version is already a little bit ahead. But the cool thing you can see, so this is a test that you run on the final deployment to make sure it's actually working. So there's a whole suite of tests that you then run on your dev and then on your QA and then on your prod to make sure that everything is working. And that's fundamentally what you have here, right? What you have here is fundamentally all of this is what you need to do, in my book, to set up dev workflows, right? And to be hyper productive. And everything you see here, and again, I use GenAI to develop a lot of this, not to give me the final code, but to work with me, to debug things, to figure out things. There's lots of little gotchas that in the past used to take me ages to solve, where now I'm ridiculously productive because, again, I have workflows like I showed on that Terraform script with Claude, especially these days with Claude, sometimes with ChatGPT, about this. So final thing I want to show you, you can see here, this is all my actions. There's lots of, so you can see the actions here use this stuff here, right? So there's the increment tag, and also you can see the update branch, publish to PyPy, right? You can see I'm using this OWASP GitHub Actions, which basically is where all the code for the that is, again, is open source. Please contribute, right? So you come in here, you can actually see all the actions that I've created that I kind of use all the time, from publishing, WS, Docker Hub, Docker, local stack, star. This is the one, increment main, right? And then you got poetry, run tests, etc., right? And then the PyPy publish is there. So if you look at increment tag, this is the tag that then receives a major versus minor sort of input, right? So kind of what release type it is, right? And then this is, to be honest, this code probably needs a bit of a refactoring, right? But it kind of works really well. I kind of understand it, but it kind of, could do with a bit of a cleanup. But again, this was I think it's one of the first things I developed with ChatGPT, right? To help me with a lot of these little ones. And by the way, the first versions didn't work, right? And ChatGPT, even Claude, like if you just say, create one of these, sometimes it goes off piece. But as you work the little bits, if you break the bits in pieces, then it does a really, really great job, right? So again, like, I cannot stress how critical is the whole tagging thing. Because look, you can see here, I can go in here and I know that my main is now deployed, right? In fact, there's other workflows you can do more advanced where you can even have tags to tell you, other deployment states. But this means that when I have my multiple projects and each project depends on another project, I use the tags and I know exactly what's been deployed. I can go back. I can basically. It's very easy to go back a version. It's very easy to create, a rebase, take something out. So I cannot stress how critical it is to go into this mode, and then it just becomes second nature. Like, I cannot program any other way these days. But it has to be automatically. It has to be on the pull, on the push to a dev or a main or whatever branching strategy you have, it cannot be manual. If it's manual, people won't do it, right? And it just doesn't work, right? It has to be automatic because you get these visual clues on there. So there you go, right? That's the DevOps workflow. The final little thing I just want to cover, I think this is really cool. I think you should check it out, right? Fundamentally, what this is that architecture that actually I got on this other document with the thread modeling, right? Is a kind of a variation of, you could see that, the architecture is like this, RSS feeds, feed crawler, and then I put it, in the SDN, on the CDN, which is basically out front, or I have a fast API connection to it. And what's really cool about this is you go from having a client attack surface, which is this Lambda fast API S3 bucket, to literally this, which is what I would argue every time you have, for example, public data, it should be like this. There's no reason to have a server. The thing is public, it's static. Write is that write once, read many, right? So sometimes we actually over-engineer a lot of stuff. And one of the things I like about this description here, it's the fact that I have this crazy productive environment where I spend a lot of time in my DevOps pipeline. I spend a lot of time in the architecture, a lot of time in making it as simple as possible. I arrive at that solution. I was like, why don't I just put it on S3, right? And in a weird way, it actually, this is the one that has the really cool article, the really cool, but you can see here, right, the different vulnerabilities. You go from normal to almost none, right? In fact, there's a couple lows here, and even the strides is a bit like the other one, right? The stride on new solution, you got 4 none, 1 by design, and then 1 low, right? Which is great. This is what threat modeling should be about, reducing the stuff, right? The thing I really like here is this idea that security to performance, right? So it's like this idea that the security, in a way, was the security requirements that I had, and the idea to make it simpler and simpler and simpler, and to remove the attack surface that led me to that solution. And I think this is where security adds a lot of value, because in a way, the less moving parts, the less bits to attack, the safer the whole thing is, right? You cannot do SQL injection, right? If you think about it, like when there isn't a server on the other side, where there's no inputs, right? You cannot, spoof when the data is already there. You cannot elevate privileges when that part is. Now, it doesn't mean that in other areas you won't have this, but it means that you can then segment your application into all sorts of different things, right? In fact, just finally on that one, if you look at the architecture of the cyber boardroom, one of the things I've done was I pushed everything into what I call, for example, the user data. So I have a separate repo just for my user data, and then a user session, and then my user data is the only one. This is the one that needs the user, and on that API, every single one needs to be given a user. If it's not given a user, it will fail. Right? So that's, again, a good example of without a user, you don't have access to the data, you cannot even access the right buckets or right information. So again, it's a good example of security by design. And again, all of these have that. You could see, okay, this actually is a recent one, has 39 tags. But if I go into one of the big boys, right, that I've been doing for a while, right, you could see that the tagging is a bit bigger, right? So this one has 1,193 tags, right? So just to be clear, every one of those was released, right? Every one of those is a dev that arrived at the live server that I can test, right? And that's the power, right? That's the power of the DevOps pipeline, is I release all the time, literally all the time. And then what you want is a situation where when something breaks, you want to have a very clear understanding and very quick feedback of something breaks. So I'll show you, to end, a very simple example of things breaking. So if I come in here and I change my route, right, or I add a new one. Let's say I'm going to add a new one, right? I'm going to add a new route. I'm going to call it, ping 2, right? And I'm going to wire it up here, because actually, if I do this, not a lot matters, because I haven't wired it to the outside world, right? In a way, that's not a major problem. The problem is once you do this, right, it means I just literally wire this up to the outside world, right? And because I haven't added a change here, what you're going to see is that when I do this, right, and I'm going to commit to dev branch, my tests are going to fail, because I have 2 very specific tests that check for the attack surface of this app. And that's kind of what you want, right? You want to have these workflows where fundamentally, right, you have a very strong understanding of the changes, and then you test things across. So every time I have a change or a bug that I don't understand, it's super critical that you then go around and add tests for it, right? And I guess one more little thing from while that runs from the testing point of view, one of the most important things you can do when you run this kind of development is to write tests for everything, including for bugs. So these days, every time I have a bug, what I do is I write a test for, and that to replicate the bug, and I have a presentation just on that. And then when that passes, it becomes a regression test. So the best example I think I have here is this part here, where are my type safe tests and my bugs. Okay, so this is my tests, but I have one that actually has bugs. Where do I put it? Oh, I'll just search for bugs. I'm sure I'll find it. Right? Bug. And I should have a whole pile of them here. And tests, test apps. Oh, here you go. Right. So that's my regression tests, and I'm pretty sure that, oh, it's on base classes. That's why I define. Okay. So you can see here, I have this test, and then I have another set, and this is already quite comprehensive. And in fact, I used ChatGPT to help me to write all sorts of extra variations, which is quite cool. So that's the other thing that's really good at writing edge cases, right? And then here I have a couple of bugs. So I documented the bugs. So you can see here, right? There's the bug, right? This is a bug, etc. So I know that while this test passes, this bug, right, still exists. And the bug in this case is a behavior, right, that I want to be aware of. But more interestingly is that this is all the bugs that I had in the past that started like that and now are regression tests. And this free set of tests gives me a lot of confidence that every time I make a change to what is quite an important class, I don't get a massive blast radius, and I immediately get feedback on what happens. So final one, you can see that I got 2 failed tests here, right? Remember that we made a change on ping 2, and you can see, look, this basically tells me that I have an extra method here, which is called ping 2, and the same thing here, right? And the thing there. So there's 2 tests here that would have need to also be fixed, which tells me that I now have a new API that wasn't there before, right? So there's a good example of that is not going to go into anywhere production until that is fixed, right? So that's what you do, right? You push changes and your test validated. But to wrap it up, it's all about the DevOps infrastructure that these days, again, use GenAI to really help you to create it and to maintain it, not to basically run the whole thing for you as a black box, but to make sure that you have a very good understanding of what's happening. And I really feel that one of the next steps of software development and even security assessment is the creation of all these artifacts of how things work throughout the pipeline, which then gets verified by the developers, by the architects, and by reality, right? What actually happens in the real world. So there you go. So I don't think there's any questions. So please, check the video. We're about to publish this new cool thing where you can start talking and checking the session. So hopefully you'll be able to, again, pick particular parts of this presentation and just delve into that. Thanks for your time, and I see you guys in the next sessions.